today we've had some fun with the shaded area problems, and we did 4 problems in class, and they ranged in difficulty, and I was going to review the 4 problems, starting from the easiest problem and working to the hardest problem. And then tonight, if you're stuck on your homework, hopefully you can try these techniques. So we spent a lot of time looking at rectangles and triangles and using rectangles and triangles to find shaded area. And so this first problem, the goal was to find the area measured in square units of the shaded region. So we just want the pink area. And this was pretty easy for everybody. So if you count down the grid here, you know this is 4 square units or 4 units long. And if you count across the grid, it's 7 units long. And so when we look at this whole rectangle, since we learned about rectangle area, we know the area of the whole rectangle is 28 units. So because it's a 4 by 7, it's 28 units. But the triangle is just the bottom half of it, and that's all we're looking for is the pink area, because 28 divided into 2 parts is equal to 14. So that was the first problem that we did. I think the second problem that we did was actually this yellow one here. So again, we're trying to focus on how to use grid area to think about triangle area. So I noticed when I walked around the classroom on this problem, so many people automatically drew a line separating these two. And they noticed all kinds of things. One of the common things was that these 4 pieces, like this being section 1, this being section 2, this being section 3, and this being section 4, were all the exact same size. And there were so many ways to solve the problem. But I think one of the most common ways was that people sort of thought of, let me get a little picture here, of area of a rectangle, right? Whoops, got a circle, I have to do that again. Thought of the area of a rectangle like just this half of the rectangle, because they could visualize how that half of the rectangle is the same as the area of the whole triangle. So in other words, like if they move that rectangle out of the picture, and I'll just put it right here. Oops. And think about the length of that rectangle and the width of the rectangle, you could see from up here, this is 1, 2, 3, 4 units. And if we count on the side, 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So 4 times 9 is 36 units. And that triangle is just half of it. So area 1 plus area 2 is 36 units. And since 36 divided by 2 is 18. We knew that this is 18 units. This was 18 units. This is 18 units. And that is 18 units. But these are the ones we want. So the total shaded area is equal to 36 square units. Because that's what 18 plus 18 is. Then we went back and did this green one. So I noticed that students, as I walked around the room, drew a line like that. And they thought of this as 2 rectangles. They looked at this rectangle here. Let's switch the color so you can see that better. And they also just looked at that alone. And so if you just think about that rectangle right there, it's 3 units, because down here you can see it's 3 units by 1, 2, 3, 4, 5 units. So that rectangle is 15 units. And if I divide 15 by 2, I get 7.5 units. So the top part's 7.5 and the bottom part's 7.5. Similarly, if I draw another rectangle, different color, right there, make that a little see-through, that rectangle is 1, 2, 3, 4, 5 units by 1, 2, 3, 4, 5, 6, 7, 8 units. So the area of that rectangle is 40 square units. And so half of that rectangle is 20. So there's 20 there and 20 there. So the total area, the shaded area, is without the value of 20 plus 7.5, or 27.5 square units. And then the last problem we did was more challenging. So let's see if I can help you visualize this one. So if I take a big rectangle, just looking at this whole rectangle we did together in class is 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 7 times 12 is 84. So when you look at that rectangle, if I pull it down here and draw a line from one corner to the next, whoops, let's try that again. Draw a line from one corner to the opposite corner. I just divided that rectangle in half, and so the top half has to be 42, because if I divide 84 by 2, I get 42. So I know this is 42. And this is where the problem gets challenging. we still need to figure out this part over here. We don't know what that is. So if I draw another rectangle just like this, and I want to just figure out this half of it. So I'm not going to worry about that up there. So if I just think about that half of it, I can take that rectangle and just sort of draw a sketch of it above it. It would be 3 units, because it's 1, 2, 3 by the same 7. So it's 21 units. So I'm going to erase all of this, clean it up a little bit. But I just want the bottom half of it. So I just want the bottom half. So I'm going to take 21 and divide it into 2 parts, and that's 10.5. So that's the bottom half. So just to make that a little bit easier to visualize, and also sometimes doing something twice is helpful, I looked at this rectangle here, and if I pull it out of the picture, the dimensions of that rectangle were 3 by 7. So the whole rectangle was 21 units. But I am only interested in the bottom of the rectangle. So I divided 21 into 2 parts and got this to be 10.5. So now I have 10.5 and 42, but the whole thing is 84 square units. The whole rectangle is 84 square units. So I have to take my 84 and I'm going to subtract out the 42 plus the 10.5. So that's 84 minus 52.5. And when you subtract that, you get 31.5 square units. So that was kind of a level 3 problem. So it's a great one to understand, but it may take a few practice examples.